So today we will cover a brief overview of renewable energy technology as a whole, what it is, how is it different from fossil fuel based non-renewable energy technologies, and then show its current status in the world and in the Indian context. Now, what are the various renewable energy sources that exist in the world? Okay. If we look into that and try to see that various sources that exist, we can group them up into various types. The first type is the kinetic energy of water, of moving water. Okay, this is one of the oldest and most traditional forms of renewable energy technology. Here the conversion technology is a hydropower plant which is harnessing the kinetic energy associated with moving water as it flows from high altitude mountains towards the sea. And the usage here is electricity generation through hydroelectric power plants. And the advantage here is the technology is very well established. We have hydroelectric dams in many parts of India and many parts of the world that has been operating from the 19th century even. It would be interesting for you to know that the first hydroelectric power demonstration was done just 5 or 6 years after the first coal power plant demonstration by the Edison Electric Company in Niagara Falls. So, as a source of energy, hydroelectric power plant is as old as the oldest form of industrialized power plant, which is the coal power plant, right? The disadvantage is there are sustainability issues with hydroelectric power plants that we will discuss later. Firstly, it's seasonal. So during the dry season, the river dries up its flow. So very little electricity is generated during the summer times or in the winter times when there is no flow at all. Okay. So it's a seasonal source of electricity. Then constructing large scale dams causes a significant amount of damage to the river ecosystem, can have flood risks, and often these resources are geographically limited. They exist in remote regions, in mountains, etc., which are far away from human sources, human habitation sources, which usually are in coasts. Okay, very few people live in the mountains. More people live in the coast or in the flat plains of rivers where there isn't a lot of velocity in the flowing water. So there is a distribution problem there as well. So there are certain disadvantages in this form of technology. The next type of energy source is the kinetic energy from wind. So again, this is reasonably well established. The conversion technology is wind turbine farms. It's a modern renewable in the sense that as an electricity generation source, wind turbines came into vogue and became popular only from 1990 onwards. However, as a technology, windmills have existed for a very long time. So the kinetic energy had not been used to generate electricity, but it had been used to run machines in farmlands, etc. Okay, so that technology is well understood how it works. Only that modern technology has made it possible to harness it to generate electricity on a large scale. Okay, so it has high potential and is rapidly growing. Okay, so wind turbine based electricity generation is one of the fastest growing renewable energy sectors in the world today. It also has its disadvantage. Wind is intermittent. The wind velocities fluctuate very much, and so the energy that is coming out of it is also highly intermittent. Sometimes there is a lot of it, sometimes there is very little of it. Also, like hydropower, the windy areas are in the mountain sides, which are far from population centers, or in the offshore, which is also quite far from population centers and is hard to move electricity from offshore wind power plants to the coasts. Okay. So there are certain issues, distribution issues there as well. Next, we look at solar radiation energy, where the conversion technology is solar photovoltaics. So the light energy that is present in sunlight, the electromagnetic wave energy, the energy of photons, that is converted directly to electricity through solar photovoltaics. This is an extremely modern form of renewable energy technology that came into being with the semiconductor industry, because the semiconductor chip, the PN junction diode, those are precisely the technology that is required to convert photons directly into electricity. So this area of technology has been growing only from the 1960 onwards, and solar power plants, solar cells and solar farms have become a rapidly growing form of electricity only in the last 10-15 years. It has very high potential, the fastest growing energy sector, renewable energy sector in the world, and most of the investment in today's world is in either solar or wind farms. Disadvantage: there is no energy source at night, so it is only a daytime energy source, and it is also intermittent in the sense that if there is cloudiness, the solar power generation falls quite dramatically. So that is a problem. So it's also an intermittent resource that is there sometimes and other times it is not there. Another way you can harness solar energy is through solar heat systems. These are called solar thermal conversion technologies, where solar energy is converted to heat, and then this heat is used for direct heating or electricity generation. So for example, your solar cookers or solar water heaters are a way where the solar energy is converted into heat energy, and then this heat energy is being used directly. There are also solar thermal power plants that is transforming this heat energy to electrical energy, and this is also being installed in some places. Okay, it's a very good source of heating. As we will discuss, many industries require heat, and for example, furnaces, boilers, direct heating, hot water systems, etc. And converting renewable energy to electricity and converting electricity to heat is very inefficient. So if there is a renewable source, and solar heat is one of the few renewable sources that is directly converting a renewable source into heat rather than to electricity, has a large potential in solving the heat requirements in industry and residential sectors. But if it comes to electricity generation, this is more costly than the solar photovoltaic technology, which is why it is lagging behind the solar photovoltaics when it comes to electricity generation. There is another way to get heat, which is geological heat source. So geothermal power plants. It can directly do heating as well as electricity. The hot water sources in mountains through geothermal systems, that kind of heat systems can be used where there is a significant source of subterranean heat, subterranean water vapor, hot rocks, etc. It's an established technology. There are geothermal heating systems or power plants that has existed for a very long time now, but it is extremely scarce. Only a few places in the world have sufficient geothermal heat close to the surface for it to be tapped economically. So even though it's established and very useful where it exists, it does not exist in a lot of places. And in India particularly, I am not aware of a single geothermal heating power plant systems in existence. Okay. Then there is biomass. This is basically natural wood source which can be used to convert them into biofuels. So we will discuss this later. So agricultural residue, forest residue, certain types of energy crops that are grown particularly to be converted into bio oils that can be directly added as an oil substitute in cars, trucks, aircrafts, etc. So these are basically called biofuels, and these are substitutes for fossil fuels, where instead of mining coal, mining oil, you are basically growing crops and converting those crops, the oil of these crops, into the oil that you need to drive your vehicles or to power your power plants. And in that way, you are not releasing any carbon which has been sequestered for millions of years inside the ground. The carbon that is being generated by burning of these biomass sources has just been trapped by the plants that have been grown last year. So the net effect in CO2 is likely to be significantly less compared to burning fossil fuel systems. We will see issues with that in the later that it's not entirely carbon neutral. We will see how to ameliorate that, but it is also a source, a very flexible source of renewable fuels, heating and electricity. And one of the advantages is it can pair well with the existing combustion centric technologies. So a coal power plant can very well run with wood chips or sawdust, which is forest residue, forest industry residue, or a car can run on gasoline substitutes that have been gasoline substitute oils that have been generated from biomass. So you do not have to change the technology wholesale for this substitution to occur. So there is an idea of drop-in fuels in transportation sector, where drop-in biomass based fuels are replacing the fossil fuels to a certain extent, and that is decreasing the net CO2 emissions from them. So it's a sustainable energy technology. We will see whether it's sustainable or not in the future, because there is a disadvantage that unsustainable production of oil crops can also harm ecology and cause pollution. Okay, because if you are clearing forest lands to grow your oil crops, that itself is a harm to the ecosystem. Okay, so we will discuss the overall sustainability of biomass later in the class. But these are the main types of renewable energy technology that we will discuss over the next few classes. Okay. Today I will kind of also look at what are the main. So we have looked at the various resources. What is the amount of each resource that is available globally? So this slide basically looks into that. Okay. So here we have three major sources of energy that is coming to Earth fundamentally. One is from the energy of the sun, the sunlight and the associated heat that is coming from the sun directly. The energy from Earth. So here basically it's a geothermal heating of the subterranean heat that is present on Earth. And then from planetary motion. This is the motion of the tides. The gravitational energy between the sun, the earth and the moon is generating tides, and this tidal motion also has some energy in it. So there are three fundamental sources of energy that exists on Earth today. The primary one is from the sun, at least on the surface, then geothermal and then planetary motion. Okay. How much energy is actually present from these three sources? Okay. So here the unit is the unit of power in terawatts. So mega, giga, tera, exa, right? It's in tera joules per second. So how much energy per second is coming to Earth on average from all these sources? So part of the solar energy is being reflected back into the space, but that which is being absorbed by Earth is around 120,000 terawatts of energy. So the sun, Earth is absorbing 120,000 terawatts of energy from solar radiation. 50,000 is getting reflected to space through clouds, etc. Compared to this, geothermal energy is only, at least on the surface, we are only getting around 30 terawatts of energy from geothermal sources. So you can already see a large disbalance. Sun is the main source of energy on the surface of the Earth at least. And planetary motion tides only 3 terawatts of energy, very small. Okay, and we can compare these values to the total current human consumption. The total current human consumption is 19.2 terawatts, so around 19 terawatts, and this is likely to grow to twice or thrice the level by the end of this 21st century. So you can think of around 30 terawatts kind of the expected value we will be going to by the end of the 21st century, for example. I'm talking loosely. We can look into the expected energy budget if you look into some papers on that front. So we are seeing that we are quickly going to a space where geothermal, certainly forget tides, even geothermal will not be able to cater to the human energy consumption. So somehow if we are going to switch entirely to renewable energy, we have to look into the solar energy budget and extract solar energy for our energy conversion needs, either fully or partly. We can use geothermal where it's available. We can use tidal power where it's available, but most of it has to come from sun in some way or the other. And when I mean sun, I do not only mean solar energy, because understand, out of this 120,000 terawatts of energy that is coming, 80,000 is coming as sensible heating. It is heating up the surface, the atmospheres, the oceans, etc. 40,000 terawatts is going to evaporation of water. So all the part of that heat is being absorbed, and water is transitioning from liquid to vapor and going up into the atmosphere, forming clouds, creating the precipitation events and all of these. 300 terawatts is going to the kinetic energy of winds and the waves. Okay, so wind turbines and wave driven power systems, that energy source total in the world today is around 300 terawatts. So the kinetic energy of wind, how does it come from the sun? Basically, it's differential heating of the earth's surface which causes pressure levels to fluctuate, and the fluctuating pressure levels drives the air from the high pressure zone to the low pressure zone. So the kinetic energy of wind is fundamentally coming from the heating impact of sun on earth. So the thermal energy of the sun is heating up the atmosphere and the oceans, and this heat and the differential heat fluxes there is driving the motion of winds and the waves. So that is the kinetic energy. Okay. Then the latent heat of that is being absorbed by water during its evaporation process is what is causing the water to rise up in the atmosphere and fall as rainfall on the mountains, and that water is now flowing down the slope into your oceans. So this entire flow of water from high altitudes to low altitude is driven by the evaporation cycle driven by the sun's heat. So this 40,000 terawatts is directly related to the total hydropower that is available on earth today. Okay. The sensible heating part, basically you can use solar water heaters, solar buildings, solar dryers and ocean thermal energy. So all your solar heat systems are getting its energy from this system. Okay. Then 100 terawatts is being absorbed by the living world, by the plants, the grasses, the trees, the phytoplankton in the oceans. They are absorbing 100 terawatts of the solar energy for its photosynthetic needs. Okay, so the entire world's biomass, the entire living ecosystem is supported by this 100 terawatts of solar energy that is being converted to leaves, green leaves, planktons, etc. on the land surface and in the ocean surface. So the entire biosystem is driven by this 100 terawatts of solar energy power that is coming to the earth. And the biomass and the biofuels are a part of that. Okay, so our agricultural resource, our biomass resource, our biofuel resource is a part of the living ecosystem's energy, which is fundamentally limited to around 100 terawatts. Okay, of course, the natural ecosystem has to thrive as well. So here we are seeing that the biomass actually has relatively small amount of solar energy in it. So here also we have a resource constraint on biomass, because if we are consuming 20 terawatts today and likely to consume 40 or 50 terawatts tomorrow, we cannot get it all from biomass. Yes, biomass can do a part of it because the rest is needed for agriculture, for the natural systems, forests, natural oceans, etc. Okay, but these ones, the sensible heat, the direct solar energy, the solar photovoltaic systems, here the resource constraint is far less. There is ample energy that is coming there. So here we can actually use a lot of it without a significant concern to the environment. Okay, so these ones have low sustainability concerns, at least when it comes to energy fluxes. Okay, whereas these ones, if you are trying to convert a lot of it, there is possibility of resource constraint. So that's the kind of a division that I am making here. Okay. So today I will stop with this final slide, which kind of shows the difference between renewable resource and a non-renewable resource. What is the difference? Okay. So examples of renewable resource we have discussed: wind energy, solar energy, biomass energy, and even tidal energy. We will not discuss tidal a lot because frankly no power plant exists at a commercial level that is doing tidal. We can look at it later if we have time. Then we have conventional energy sources are basically coal, oil, gas, radioactive ore like uranium. Okay, so nuclear energy is actually a non-renewable resource because uranium is primarily non-renewable. The source is different fundamentally. The source of wind, solar, biomass is the natural local environment. The solar energy, the wind that is blowing, the water that is flowing from the mountains, that is the source of this resource, renewable resource. Whereas the source of conventional resource is a concentrated stock. A concentrated stock of oil, coal or uranium that is being mined from certain places and is moved. Okay. The normal state of this source is a natural current or flow of energy. There is a radiation flux. There is a velocity flux. So it's kind of a flux that you are diverting and creating power. There is a flux of wind velocity, kinetic energy flux, right? Heat flux, etc. Whereas the normal state here is a static store of energy. So the coal is a static store of chemical energy. Uranium is a static store of nuclear energy. There is no natural current or a flux that is flowing. It's a static store. It's a capital energy system. Another very significant difference is the average intensity of this energy. So the renewable sources are low intensity sources and is dispersed. The typical values are around 300 watts of energy per meter square of land area. So for example, if you think of wind, there is a limit of how much wind energy is available at a certain area of land on which the wind turbine is situated, or how much sunlight is hitting a certain area of land, and the values are around 300 watts per meter square or lower than that. Okay. Whereas the energy that is present in this concentrated stock of fossil fuel or concentrated stock of uranium ore is much larger. When you are burning a fossil fuel, you are releasing more than 100 kilowatts of energy per meter square of that fuel being burnt. Okay, so it's a concentrated high energy stock which requires very little land area to store. So the energy density is very high of this concentrated stocks, which makes it super convenient to harness within a small power plant or within a small nuclear ore reactor. Large amount of energy can be released very quickly in a very small amount of area. Okay. Whereas here you need a large catchment area. The river requires a large catchment area to get its flow sources. You need large solar plants or large wind farms to harness the much highly dispersed or diluted flux of energy that is flowing in nature. On the other hand, the lifetime of supply is infinite for renewable sources. The sun will shine for the next 4 billion years, and as long as the sun shines, the wind will flow, the water will flow, right? So it's an infinite compared to human existence. Whereas conventional supplies are finite. We already have concerns with how much oil is left, how much coal is left, how much uranium is left in the world. So it's a finite resource, and there is a lot of pressures, supply demand pressures on this resource. The cost of the source is hence free. Solar energy is essentially free, wind energy is free, water is free. Whereas the conventional energy supplies are increasingly expensive. The oil, the crude oil, the coal or the uranium are expensive things to procure because it's finite. On the reverse side, the capital equipment investment to harness this free source of energy is much more expensive than this concentrated stock of ore because it is concentrated. So you have much lower technological challenge in harnessing this concentrated power. Whereas because it's dilute, the technology has to be sophisticated to harness it at a very efficient value and at enough rate for it to be commercially viable. So the initial cost of capital equipment is much larger for renewable supplies than for non-renewable supplies. And it also explains why our initial industrialization happened with conventional energy sources. It happened that way because the technology to harness concentrated stocks is much easier to develop than technology to harness much diluted stocks of energy. Another issue which is a challenge for renewable energy is its intermittency. It is very hard to control the energy flux, the natural flux of energy. Wind stops blowing, the wind flux stops. The solar flux stops at night, right? So it's difficult to control it. To get a consistent supply of electricity or heat out of it is very difficult. Whereas because you have a stock which you can supply at a certain rate, you can ensure a steady controlled stock of fuel coming into your furnace or your reactor, and it burning at a steady rate to generate a consistent source of energy throughout. Okay. The location of use is site and society specific, because as we discussed, wind turbines are the locations where wind is blowing at a high enough velocity are often far away from locality. Your hydroelectric dams are obviously limited by where you have strong flowing river currents. So there is a site and society specificity to most of the renewable energy supplies. Whereas conventional energy supplies, you can buy oil and produce your and put it in a petrol pump. You can buy coal and produce a power plant anywhere you require. So the geographical limitation is not there. Okay. When it comes to scale, the small scales are often economic. You can have micro hydro turbines, micro wind turbines, a single solar cell on your rooftop. It is economic to do it in a small scale. Whereas for conventional energy supplies, large scale systems are usually more economic. Okay. So a household gas turbine power plant burning natural gas does not make sense, but a small scale solar rooftop solar does make sense. Okay, so there is a issue of what is the scale at which you have good economic returns. The rest is not that important. Of course, pollution and environmental damage is less in renewable systems compared to the non-renewable systems. We have been discussing this so far, and the rest are not that important differences. Okay, so this kind of gives you an understanding of what a renewable source is and what a non-renewable source is. And the various the differences in the technological challenges to harness each, and which is why we require a different set of technologies often to develop our renewable resources compared to our non-renewable resources. And we will discuss this as we look into many of the technologies that we will discuss in the future. Okay, so with that, I'm going to stop today. I hope the presentations remain clear. We can have doubt clearing sessions, of course, as we go on in our classes, online classes. And have a good day and see you in the next lecture. Thank you.